Hello and welcome to another live stream today. Happy Easter, everybody. It is Easter Sunday, so for anyone joining me today, well done for joining me. Well done for committing to your revision. So today we're going to be looking at standard form. So we're doing a math session today and we're looking at standard form. So welcome to everybody on YouTube. Thank you for joining. Please like, comment and subscribe if you haven't already. And please consider joining my Patreon. The link will be in the description below. So some people are watching on Patreon today. On Patreon, you'll be able to access this full lesson. So on YouTube today, we're going to be going over what is standard form, how to convert regular numbers to standard form and vice versa. And then we'll look at the theory of how to use addition, subtraction, multiplication and division. But only on the Patreon live and recording will you be able to see how that gets put into practice. So you'll be able to see some examples of that. So please consider joining Patreon if you haven't already. For those of you who are watching on Patreon, thank you very much for your support. Let's continue to work with this together so that we can continue to make videos like this. So thank you so much. Okay, so let's get started. So first things first, what is standard form? So what I'd suggest, if you can, is to grab a notebook and a pen so we can make some notes. Ideally, you want to be keeping this notebook for all the sessions we do together so that you can keep it all in one place. You might want to separate the English and the maths from each other. If you don't want to do that, you don't have to. The main thing, though, is to make sure that you put the date on the top of all of our note pages, so that you can keep track of when you've done what, essentially. Okay, so let's go to making the first note. So as a title today, we're just going to put standard form, and we'll pop the date today, which is the 20th of April. Okay, so what is standard form? Essentially, standard form is a method of recording numbers that are either very large or very small. So inevitably, when we have extremely large numbers or we have extremely small numbers, we end up having a lot of zeros that are not significant figures and are therefore quite difficult to read. Sometimes when you have a very large number, it's quite difficult even to have the space, depending on where you're writing it down, to write down all of those zeros. So standard form is a method of making that, literally when you're looking at it, much shorter. So that it's easier to record, essentially. So a couple of the rules with standard form, I'm going to add this in. So the format is a number between 1 and 9 before a decimal point, followed by all other significant figures after the decimal point, and then multiplied by 10 to the power of n. So n being any number. So it's about multiplying numbers by 10 to the power of something. So obviously, when we think about multiplying by multiples of 10, it could be a 10, 100,000, 10,000, etc., etc., etc. We can make numbers really large. What I mean by significant figures here are any numbers that aren't zero. Essentially, 0 can be significant, but 0 is only significant if it sits in the middle of another group of numbers. So, for example, in the number 8,900, the only significant figures there are 8 and 9, because those zeros sit at the end of the other numbers. In the number 0.000764, the only significant figures are 7, 6, and 4, because the I don't know if I can just highlight those, probably not. The zeros sit on the... No, I can't do that. Yes, I can. The zeros sit on the far left, and they're not in the middle of a set of numbers. However, if we had 87,605, all of these are significant, including the 0, because the 0 is sitting in the middle of the other numbers. So it's not insignificant because it doesn't sit at one end or the other. I'll just need to scroll down so you can see that. That's what I was intending to look at there. Okay. So I'm just going to show you a couple examples of that, and then we're going to look at how we might convert regular numbers to standard form and back again. So let's say I had the number 7,500. In standard form, that would be 7.5. So it's really important that the number before the decimal place is between 1 and 9. It cannot be 0 and it cannot be 10. It has to be a singular digit starting at 1 and ending at 9. Point, and then the rest of the significant figures. Now, the only other significant figure is 5, and then it gets multiplied by 10 to the power of something. Now, how we determine the power of something is how many times would I have to multiply this number by 10 to get to 7,500. So it's about place value. It's how many place values those digits have moved. So in this case, I'd have to multiply this by 10, and then 10, and then 10 again, so it would be 1,000. So in terms of the power, it would be to the power of 3. Okay, because 10 to the power of 3 is 1,000. So another example, let's do 809 million. Okay, so significant figures are 8.09. So that 0 there is significant because it's in the middle. The other zeros are not significant. Times by 10 to the power of, now here I would have to multiply that but twice to get 809 and then another 6 to get to the million. So that would be to the power of 8. Okay. Now if I have small numbers, let's say I have 0.000289, that would equal 2.89. So I start with the significant figures. All of those zeros at the beginning are insignificant. So I start with 2 and I go 2.89. Again, we multiply by 10. But what's important here is that because this is a small number and we need it to get smaller, not bigger, so the digits have to move place value in the other direction, the number we're going to put here is actually negative. So I have to decide how many times I would divide by 10 from here to get back to here. And in this case, it would be, I'm just thinking about how many times my decimal point moves. So say it's there now, 1, 2, 3, 4, 5. 5. So therefore, my power is negative 5. Okay, I'll do another one of those. 0.005089. Okay, so I've got a 0 there. That is significant because it's in the middle. So it starts 5.089 times 10 to the power of 1, 2, 3. So to the power of minus 3. Oh. Not there, it's always to the power on the power of 10. Okay, if I'm going the other way around, then let's say I have 7.854 times 10 to the power of 4. And we'll see what that equals in a minute. I'm just going to write a few of these down first. 3.219 times 10 to the power of 11. And then 5.21 times 10 to the power of minus 6. And then we'll have 4.0023 times 10 to the power of minus 10. Okay, so let's look at converting those. So I've got my significant figures. I need to look at the indice next to my 10 because that's how many times I'm going to be multiplying it by 10. So it's how many times the decimal point moves essentially. So it's here, it's going to be 4 times, 1, 2, 3, and then an extra 1, which means there's a 0 on the end. So it's going to be 78,540. We don't want it to be small numbers, we want it to be big numbers. 78,540. This one, again, I'm going to move it 3 times to get to that whole number, and then we're going to have all those zeros added on for the remainder of that. So that's 8 zeros it's going to be. So it's going to be 3, 2, 1, 9, 1, 2, 3, 4, 5, 6, 7, 8. I don't know why that's gone little. We don't want that. We're going backwards this time. So I'm dividing by 10 6 times because it's to the power of negative 6. So I'm going to have 5 zeros after the decimal place, because once I divide it once, I'd have 0.521, and I divide it another 5 times, so 0.12345, And similarly here, we're going to have 9 zeros before the decimal after the decimal place. So 0.123456789 40023. So those zeros there, those 2 zeros between the 4 and the 2, are significant because they sit in the middle of numbers. Okay, lovely. Right. Oh, you can't actually see that, so I'm just going to scroll down slightly. There we are. What I'm going to do now is I'm going to give you, I'll give you a minute or so just to copy a few of those down there. And then I'm going to give you some examples to have a go at on your own, and then see how accurate you are. So I'll just give you an example of each. So I'll give you 2 that's converting from ordinary numbers to standard form, one of them negative, one of them positive, or decimalised and not decimalised, and then 1 from standard form to numbers, or 2 of those, the same variation. So just have 4 questions to have a go on your own, and then we're going to have a look at a little worksheet where we're going to be looking at taking over the human race using some standard form numbers. So that will all be revealed in a moment. For those of you on Patreon, the worksheet that we're going to do when I finish the YouTube video is ready to download, and it's basically part 2 to the worksheet that I'm going to put on the screen in a moment. Okay. So just copy a couple of those down, and then I'll give you a few questions to do on your own. Okay, right. So 5.789 times 10 to the power of 3. 2.601 times 10 to the power of -7. And then we'll do some regular numbers. So we're going to have 0.00009808. What would that be in standard form? And then we're going to have 5, 6. How many zeros if you can count them? And what would that be in standard form? So just converting those now if you can. I'm going to give you a couple of minutes to do that on your own. So I shall be back in just a moment. Okay, right, so let's have a look. So this first one is 5,789. Second one is 0.0000002601. This one in standard form is going to be 9.08 times 10. And it's a negative power, so we've got to go back. We're here, we're going to go up 1, 2, 3, 4, 5, 6, 7. So -7. And then this one is a positive one, so it's 5.6. They're the only significant figures. Times 10 to the power of, so let's count the decimal places. 1, 2, 6, 7, 8, 9, 10, 11, 12, 13. To the power of 13. Like that. Okay. Right, let's have a look then at our first worksheet today. So this is the premise of the worksheet. It's kind of how I've presented it as well when I've advertised this lesson today. So we're going to be taking over the earth. So let me just read you what we're doing. So it's about spore counts, spores being like the tiny little parts of microbes and microorganisms. So Floob from the planet Blipzone 7 is planning an invasion of planet Earth to drain its resources. There is one problem. There are some pesky pests called humans living there who need exterminating. First, help Floob convert these disease spore counts into standard form so his calculations are more manageable. So for the Patreon crowd, we're going to be doing the calculations with our conversions later on. But for everybody else, we're just going to be converting these first. And then we'll look at how to do calculations in general before the YouTube video ends. And then it will just be for those on Patreon. Okay, so let's have a look at the first one. The first one is... Well, in fact, I'm actually going to give you a couple of minutes, just like we've just done there. I would like you to have a go on your own, and then we will convert them together. So you're just converting each of these spore counts, if you can see them, for these different diseases to standard form. And then we'll go through those together, and then quickly have a go at different operations and how we can calculate in standard form, and then at the end of the YouTube video, and we can do the other worksheet for the Patreon. So just on your own now, have a little go at converting all of those spore counts for me into standard form. Okay, let's have a little look. So, I might have to just change the colour here. There we go. Okay, cool. So, the first one, let's see if I can pronounce these. Clostridium botulism. So we have 32,700,000, and we're going to put that in standard form. So you should have got, let's make this a bit thinner as well. So you should have got 3.27 times 10 to the power of 7. Okay, cool. Then we've got Rhizopus stenolypha, which is bread mold. So for this one, it's 2.58. So in terms of how many decimal points we've moved, we've gone 1, 2, 3, 4, 5, 6. So times 10 to the power of 6. We then have Cryptostroma corticale, which is sooty bark disease. Okay, so this one, our decimal point will be here. So we're going to move 1, 2, 3, 4, loads. 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 1.03, because that 0 there is significant because it's in the middle, times 10 to the power of 12. Very similar down here, I believe. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 again. Yeah, so very similar. 1.04 this time, times 10 to the power of 12. Well, it doesn't look like a 12, does it? Let's redo that too. And the last one, sorry, that one was atmospheric fungal spores, just more generic. And this one is Bacillus anthracus, which is anthrax. So it'd be here. So 1, 2, 3, 4, 5, 6, 7, 8, 9 this time. So 5.62 times 10 to the power of 9. Okay, lovely. Right, so now what we're going to do is we're going to head back to our regular whiteboard. Last thing we're going to do today for the YouTube crowd is we are going to look at how to calculate, so add, subtract, divide and multiply using standard form. And then for the Patreon crowd, we're going to look at the other part of that worksheet. So, again, if you're on YouTube and you want to join the Patreon, if you obviously you'll be watching a recording of this, but all of the past recordings, including this one, the full recordings, will be available on Patreon forevermore, as long as you join, so you'll be able to see this one as well. Okay, so let's start with multiplication and division, because I think that's slightly easier. We're going to make sure we are make this pen black again so we can actually see it. Okay, so let's say, for example, we had 5.8. Let's not do that. Let's do 5.45 times 10 to the power of 5 times 5 point... No, hang on. I've got to make these work, you see. Okay, I'll do one. So we want to do 1.89 times 10 to the power of 4 times 2.36 times 10 to the power of 3. Okay. Now, that looks quite complicated, but what we have to remember about multiplication is that it really doesn't matter what order you put each of the elements in. If they're being multiplied, they could be put in any order. So what I'd be inclined to do is this. 1.89 times 2.36, so you put the numbers next to each other, and then you put the powers of 10 next to each other after that. Now, the reason for that is that we can use our knowledge that hopefully we've already got in that when we multiply numbers with the same base number, we simply add the powers together. So this is going to turn into 10 to the power of 7. And then we've just got to multiply these two numbers together. Okay. Now we could use a calculator, which I would encourage you to use. So let me just get my calculator. Oh, hang on, you can't see my screen anymore, can you? Yes, you can. That's fine. I'm just gonna get the calculator so my screen will disappear just for a moment. So where is that? There we are. So obviously you can do this on paper, but just for the sake of quickness today, we're not practicing our multiplication methods. We're just practicing standard form. So I'm going to use the calculator. There we go. Right, so let's get this one up as well. So our calculation, if I move the calculator over here a little bit, there we are, is 1.89 times 2.36. So we get 4.4604. So our answer, making sure we keep it in standard form, is 4.06. Was that what it was? Yeah. No, 4.4604 times 10 to the power of 7. Okay, so the crucial thing with multiplying standard form is to swap the positions of the numbers within the multiplication, so that you're timesing the numbers together and then the multiples or the powers of 10. Okay, so with division, let's say we have 1.89 times 10 to the power of 7 over, let's do 2.7 times 10 to the power of 4. Okay. So what we do here is we can actually also separate our numbers and our powers of 10. So we can do that divided by each other and that divided by each other. So if you had some nice numbers, you could kind of work it out like that. I would be inclined. Let's do it on the calculator for now. So 1.89 divided by 2.7 is 7 over 10, which is 0.7. And then here we would do the powers taking away from each other because we're dividing. So knowing that that's also something we have when it's got the same base number, 10 to the power of 3. Now, this isn't actually standard form because this number here is no longer between 1 and 9. So we then have to shift that. So the only significant figure here is 7. So we're going to have to make that 7 times 10 to the power of 2, because actually 0.7 times 10 to the power of 3 is the same as 7 times 10 to the power of 2. So we do need to then, if we're changing this to make it standard form, adjust the power accordingly. Okay, cool. So let's set another page. Now this is where it gets a bit trickier when we have the addition. So let's sit down here. Here we are. Right. So we have 5.871 times 10 to the power of 5 plus 6.87 times 10 to the power of 2. Okay, that's much harder. So what we're going to do here is we're actually going to convert one of these 10 to the power ofs so that it has the same power, because then these numbers here almost become coefficients in like the same multiplier. It's almost like algebra in a way. So I'll just work through that and kind of explain how we go. So 5.871, we're going to keep this one the same. Plus, now I'm going to convert this, so this is also going to be 10 to the power of 5. Now, in order for this to be 10 to the power of 5, we need to change this to 0.00687. Okay, now you can see that this is kind of similar to, let's imagine we had 5.871x plus 0.00687x. You would just add these two numbers together and put them in front of x. So in the same way, we're going to add these numbers together now and put them in front of our 10 to the power of 5. So if we look at our place value here, I'm adding this, the 6 is going to be in this place value. So it's going to be 5.87787 times 10 to the power of 5. And there's your answer. Obviously, that works in exactly the same way for subtraction. You just need to make sure that you actually subtract at the end rather than add. Okay, lovely. Right, so that's that for the YouTube video. Thank you for sticking with me. What we're now going to do for those on Patreon is we're going to look at an example of, or a few examples of these, using the alien analogy and the diseases and those in standard form, so that you can have a crack at that, some of the things I've just gone over. If you're watching a recording of this, please rewind before you do that if you want to double check how it works. And then I'm going to be going over the answers afterwards. But that's only for those on Patreon. So everyone on YouTube, thank you very much for joining me today. Please like, comment and subscribe, and feel free to click the link below to join my Patreon and see this full video along with all of the other full videos that I'll be doing weekly at 2 p.m. on a Sunday with accompanying worksheets to download. So thank you very much, and I shall see you next week when we return to an English lesson.